This is a video of how to do a one sample confidence interval using R. As always, you need to put the data into R. This data is actually called expectancy, is what I want to call this data set. We're going to read the CSV file, and this is the address for the CSV file. It's always a good idea to do header just to see what the data kind of looks like. So we'll do head expectancy. And so we see we have life expectancy, which just happens to be a variable that they have, life expectancy at birth. Indicator would be and a year, so that's the indicator. The year, the region of the world by the World Health Organization, what country we have, the sex of the people, and their life expectancy. So one thing to notice is that we actually want to have for life expectancy of both sexes in Europe. So these were countries we picked out of Europe, but it has both sexes, female and male. So we actually want to, both sexes are combined, the information combined for both. So we want to actually filter based on that variable of sex. So remember to filter, we'll call it both. I don't care what you call it, but I'm going to call it both since it's both sexes. And then you put in the variable of life expectancy, is what we call our data set. And so we want to do it on the data set expectancy, and then we're going to do it on the variable expectancy, and then the dollar sign says which variable. We want to do it on sex. Put a double equal sign. Then in quotes, put both sexes. Make sure you put that exactly as you see up here. It is both sexes is what we're looking for in the variable sex. And then as a reminder, for some reason you just put a little comma here and hit enter. If you want to, you can do a heading of the both, just to show that the data actually works. It didn't seem like it did work that time. So let's see what I typed in wrong. It's always a good idea to look through. Make sure you typed in everything correctly. I didn't because I typed both sexes, not the same as it was. So it's supposed to be both sexes with a lowercase s. And now again, do the header of both. And there it happens to be. So that was a good check because we noticed we didn't get it all in. It again grabbed all the same variables, but now it's just for both sexes. All right, so now we can run the one sample t-test. As a reminder, you need to do the QQ norm. So we do QQ norm on the both data set and on the life. All right, so we'll do a QQ norm on that. Help to spell QQ norm correctly. All right, and the graph of that looks like this. So that looks pretty good. Looks fairly linear, but we'll look at the other two graphs also. So we'll do the histogram. So remember that's hist of both $life. And so we'll go look at what that one looks like. And so that histogram doesn't exactly look like a bell-shaped curve. And it could just be because there's not enough data. Other things could be going on. So we're not really sure if this really is a bell-shaped curve, but we'll go with the fact that the QQ norm graph looked pretty good. And then just for fun, let's look at what the box plot looks like. It's the last one to look at. And it's box plot. Sorry about that. And then we'll go look at what that graph looks like. And there are no outliers. So since there are no outliers, and the QQ norm graph looked fairly linear, I would say we're safe to assume that this is normally distributed. So now we're going to have R calculate the test statistic for us. because it looks like the assumptions have been met. It was a random sample, and the population looks to be normally distributed of life expectancy. So we're going to do a t.test. We're doing it on the data set both. We're doing it on the variable life. And even though the confidence level is 0.95, I'm going to put it in there just to make sure you know how to do that. So you do conf.level equals, and then it's 0.95 that you type in there. If it was a 99%, you put 0.99, 90%, 0.90, and so forth. Hit enter, and it gives you the information. It doesn't know if you want a test or a confidence interval, so it gives you both information. We want a confidence interval, so you're going to come down here to the 95% confidence interval, and the confidence interval is from 74.396 to 78.842. It also gives you the sample statistic for what X bar is going to equal, so that's that information right there. And you have just now calculated a confidence interval using R.